Okay. Next one is the Kruskal Wallis test. Kruskal Wallis test, you got 3 or more groups. Then you are going to do the Kruskal Wallis rank test. The same assumption like the Wilcoxon rank sum test. The data must be independent. Outcome must be continuous. The data could be ordinal, interval, or ratio scale data. So let's look at the Kruskal Wallis. Okay. This is the formula. Let's look here. 12 is fixed. N is number of sample you got. So if N you got 15, you put 15 here. So 15 times 16. The T here is dependent on the rank. So if you got 15 rank, it should be 1 plus 2 plus 3 plus 4 plus 5. So on and so forth until 15. Okay. For each group. Okay, each group. So you got 3 groups. Then you are going to have it for the respective 3 groups. You sum it up. Okay. So please take note. In this part is this summation. Then you minus 3 and minus plus 1. So this one is 3 times 16 become 48. So in fact your formula got 3 parts. Part 1, part 2 and part 3. This is the similar kind of question that we asked during the exam. So you can see here, you got 3 machines, you got 15 staff. Machine 1, machine 2, machine 3. Machine 1 is the oldest one. Machine 2 is the intermediate. Machine 3 is the latest machine. So the latest machine can do the work faster compared to the older machine. So you can see the ranking here. The ranking here, the time is less for the machine 3 compared to machine 2 and machine 1. So what happen now, to do this test, you have to rank up all the machine. So you have the machine 1, machine 2, machine 3. This is the filling up time by the respective staff. So the first one 19.75, that one. Then you got number 22, then 20.4, 3, then you got 20.6 for 4. Then suddenly number 5 shifted here, 21.6, 21.8, then 22.2, so on and so forth. So you have to give ranking by the value of time. Then you have this machine 1, machine 2, machine 3, the sum of all their ranks. So the sum of their ranks here, 65, 38 and 70. So what happened now, we have 5 in each machine and we have this sum, and these 3 values are put inside the formula. So 65 squared divided by 5, 38 squared divided by 5, 70 squared divided by 5, then you sum up all this, then you combine with this formula, then you minus 48. And you get the value of 11.58. So this 11.58, you put H as 11.58. You refer to the chi-square table. Which table? You're going to refer to the degree of freedom 2. So degree of freedom 2, cutoff point is 5.99. Your value is 11.58, so it is very significant. You can see here, the p-value is between 0.001 and 0.005. Okay? And with that value, you can come up with the result. So the result is there is a significant difference of filling time between the 3 machines. Since the Kruskal Wallis don't have a post hoc, you have to do the Wilcoxon rank sum test. 1 against 2, 1 against 3. Okay, so that is the Kruskal Wallis.